Good morning. I'm Alan Brown from Nagase ChemteX America, NCU, and I'm going to talk a little bit about conductive inks for wearable and stretchable applications and the testing we've done internally as more and more of these applications go to market and the requirements needed to ensure their success. I will give a brief overview of our company, target applications we're looking at, and then considerations and testing that we've done to pick a stretchable ink. So the history of our company is, again, I don't know how many people in here are familiar with Nagase ChemteX. We used to be EMS, Engineered Material System, starting as a manufacturer of adhesives for electronic, solar, wind, automotive, lighting, and print and many other markets. We were founded in '93 as an adhesive sales organization, began manufacturing in '95. In 2012, we were acquired by the Nagase Group and proceeded to build a new 64,000 square foot facility that you see there and quickly expanded to 109,000 square feet. We changed from Engineered Material Systems as a name to Nagase ChemteX America in 2021. We do have quality certifications with IATF and both ISO 9001. Moving on to applications and requirements. So as we've manufactured conductive inks for screen printing and the industry has continued to evolve, where we're focused now, wearable devices and medical patches. And those applications generally require silver ink, carbon ink. Some of them require PDOT. Complete transparency, we do not do a PDOT, but I just wanted to mention that that material is used. Generally, these are printed on a thermoplastic polyurethane substrate or onto a PET film with a coating for a release liner. And then again, what we are doing is 99% of us for screen printing. With these applications, the inks require high elongation and stable conductivity. They've got to be able to survive that elongation and conductivity through hundreds of cycles. And then again, as we move into wearable applications and some of the medical applications, the inks, when they're put onto apparel, they've got to be washed, and a lot of that testing is still in development. So one of the first things we looked at when we were evaluating conductive inks and we found is, again, how does the circuit design impact the stretchability? So what you see here are 4 different patterns that we've tested with: a zigzag line where we've rounded the corners so they're not sharp, a sinusoidal line, and a straight line. Again, just noting the screen and cure parameters at the bottom. We tested on multiple different TPU substrates. This is not an all-inclusive list. We found advantages and disadvantages to most all of them. And then, some of them have special handling characteristics. If any of you have ever handled thermoplastic polyurethane, one of the challenges is it's got to have a carrier liner. That carrier liner has to be able to withstand 120 degrees C, because most of these inks and most of the inks on the market need to be cured between 120 and 140 degrees C for optimum properties. One of the difficulties with some of the films is, in particular, the one at the top, it's difficult to handle in a sheet process if you're doing thousands of sheets because it doesn't have a carrier film to print on. The material performs very well, but it's difficult to handle in a manufacturing process. As we, again, look at the types of fillers that are used, general trend, silver, it's going to perform better than carbon, which is going to perform better than silver chloride. And again, medical applications are generally going to have a silver for a circuit and a silver chloride or a carbon ink for the electrode. And then what you see on the left is the CI 1036 which is a silver filled material on TPU.